Assalamualaikum and hi to Dr. Mahfuza. I am Nur Faiza from Group 1 and my partner in presenting our task, Gan Mengli. Me, Faiza, will explain about the solution for Fourier transform and Mengli will explain about the graph of space spectrum and amplitude spectrum in MATLAB. So this is our question. Ft equal to exponential at for the range t more less than and or equal to 0, and for range of t more than 0, exponential of minus at. A more than 0. Okay. For this equation, fj, which is the property of fj omega equal to integral of from minus infinity to infinity ft exponential minus j omega t dt. For fj omega from since the range for t is t less than or equal to 0, that means from negative infinite to 0. Okay, from negative infinite to 0, the ft is e exponential at times with the exponential negative j omega t dt. Okay, plus with the next range for t, that is t more than 0, from integral from 0 to infinite, the ft is negative exponential negative at times with exponential negative j omega t dt. Okay, for the solution, fj omega equal to fj. Okay, for until this, from negative infinite to 0, since the exponential times with exponential, we can just add the power of both exponential, be like this, exponential at minus j omega t, and this just the same. Okay, we can plug take out the t, that's exponential t in bracket a minus j omega t dt, to easy for us to easier integrate the equation. Same goes to the next, this one, and we can integrate. The properties is exponential t a minus j omega t over with the differential of power of the power of exponential. We get a minus j omega, and this one is the same. The differential is minus a plus j omega. Okay, next we just plug in the value of 0 and minus infinite to this for the first equation, and 0 to infinite for the second equation. Power exponential 0 equal to 1, so we get 1 here. A minus j omega exponential negative infinite, we get 0, and same goes to exponential minus infinite, we get 0 too, and exponential 0, we get 1. Okay, then we get like these questions. To combine the both this one and this one, we just multiple we just uh, uh, intersect multiple. This one is this and this is this, and we equalize. We times the we time this one, and we get this a plus j omega plus a minus j omega here, over a square minus j square omega square, since j square is equal to j square is equal to minus 1 minus 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 1. Okay, then minus become plus, so the final answer is 2a over a square plus omega square. Okay, next our task is we have to find the graph for both amplitude and phase spectrum, and in using MATLAB. Then mainly we'll explain about this solution in MATLAB in the next video. Okay, thank you.
Hello everyone, here I would like to show how to plot the graph of both amplitude and phase spectrum using MATLAB. First of all, we need to declare all the variables in the function first. Here it clearly shows that the function have two variables, which is a and omega. Since a is a constant, so here we just simply put a equals to 1. And for the omega, we need to set the range for it. So here we set the range for the omega is equal to negative 6 pi to 6 pi. And then now we have to clearly show the equation for the function. Here it clearly shows that the equation for the function is equal to 2a over a power of 2 plus omega power of 2. The bracket we need to clearly show in the equation to ensure that the equation are in a correct form. Now I would like to show how to plot the graph for the amplitude. This is plot the graph of omega and with amplitude spectrum of y. Then we can set the title for our graph. And here we set the title from the graph is amplitude plots. And the label for the x-axis is frequency. Label for y-axis, we put it as amplitude. So this is the graph for the amplitude. It is same like what we have declared. For the title, it is amplitude plot. The label for y-axis is amplitude. The label for x-axis is frequency. And this is the graph for amplitude spectrum of the function. It clearly shows that the graph is a symmetrical graph. So now I would like to show how to plot the graph for the phase spectrum. It is same like the coding before. We need to set the title for the graph. So here we set the title for the graph is phase plot, and the label for the x-axis we put it as frequency, and the label for y-axis we put it as phase. Here it clearly shows that the phase spectrum of the function is equal to 0. Since our amplitude spectrum is a symmetrical graph, so this is a unique case for it. So we also show this is the phase spectrum graph for the function, which is a 0 graph, and the title for the graph is phase plot. The label for the y-axis is phase, the x-axis is frequency. So that's all from our Group 1 presentation. Thank you.